Let's take a look at a question here. So we want to find the length CD. Okay, CD means that we need to find the length of the line segment from C to D. So that is this part right here. Now, to solve this, okay, this is what we're going to be dealing with when we talk about multi-triangle problems. We have two right angle triangles in here. And now if you see a flat line with a perpendicular line coming off of it, we know that both sides are going to be 90 degrees. Okay, so we can use that to kind of represent both sides or both triangles in that case. Now, we want to find this side here, and to find this side, we need to know one other side of the triangle. So we have to either know this side or that side of the triangle, neither of which we know. Okay, so we have to then, so we can't actually solve for this without knowing one of those two sides. That being said, this side of our triangle, okay, and I'm gonna quickly label it here, really quick, based on this angle. This is our hypotenuse, this is our adjacent, and this is our opposite side. And I'm gonna color in this triangle with pink, just to represent that this is one of our triangles. Okay, so that's our opposite side of that triangle. We want to try to find that, and right now we just can't. We have another triangle here. I'm going to shade this one in an orange. It's a bit bigger. I think we can handle that. Okay, this triangle, we have a couple pieces of information, and so we can hopefully use those pieces of information to solve for our opposite side of the first triangle, or this could be the second triangle, the pink one. We have our angle, meaning that this is our adjacent side, this is our opposite side, and this is our hypotenuse. Now, if we can possibly find the opposite side of the orange triangle, you'll notice that it's exactly the same length as the opposite side of the pink triangle, meaning that we could then find the hypotenuse of the pink triangle. It just means that we're going to have to do two different steps. So let's do orange triangle first. We want to try to find, we're just going to label it as orange. We want to try to find the opposite side. And we have the adjacent, so we're going to use tan. Tan of theta is equal to opposite over adjacent. And when we plug this all in, we don't, forgot to put the angle in there, sorry about that. Okay, this is 28 degrees, that was our angle. Opposite over 14 centimeters. Put that over 1. Okay. And we're going to cross multiply and divide, and we're going to get the opposite side to be, do 14 times tan of 28 divided by 1 is 7.44 centimeters. Now, that's a rounded number, okay? And if we can, we don't want to use rounded numbers. We always want to use numbers that are accurate. So if we can keep this number we want to, we don't need to write it all down, but we can put it in there for now. I'm going to leave it on the calculator. Not going to get rid of it yet because we're going to use it almost right away. So that means that this side right here, and I'm going to put that in there, is approximately 7.44 centimeters. Now we know the opposite side of our pink triangle, and we can find the hypotenuse of the pink triangle. So we're going to put pink down here. And if we want to do opposite and hypotenuse, that's going to be our sine function. Opposite over hypotenuse. And so sine of our angle, this is now a different angle because we're doing our pink triangle, is equal to opposite, which is 7.44 centimeters, over our hypotenuse. And again, we're going to put that over 1. Now we can cross multiply and divide. Now if you use 7.44, you're going to get pretty much the same answer, but it could be somewhat different. And so if we can, i.e. we have it right there, we want to try to use that value. So when we cross multiply and divide, we're going to be taking this number times 1 divided by sine of 50. We have that number right here. So on your calculators, you can just hit times 1 divided by sine of 70. And now what it does is it automatically takes your previous answer and plugs it into the new equation where you wanted it, and we get a length of 7.92. So the hypotenuse is equal to 7.92 centimeters. So this then is our final answer. We round that to 2 decimal places. We don't need that anymore. But we can find that the hypotenuse, or length CD, is equal to 7.92 centimeters. Okay? At this point, then we round it because that's our final answer. This isn't a final answer. We try to keep it as many decimal places as possible. Once we get to our final answer, that's when we can round. Now, this is one way of doing a two-triangle problem, and we're going to take a look at a few more examples coming up in finding two-triangle problems. There's a list here of some different ones that we could have. Okay, so finding a side length when not enough information is known. Well, we didn't know the opposite side to find the hypotenuse, but we could solve for that later on. We might need to find a partial length when only part of a side is needed. We'll see an example of that coming up. Finding a length when extended over two triangles. So imagine we had to find this entire length from A to C. We have to add these two pieces together. So we'd have to find that side and add it on. Adding two angles together to find a larger angle. So imagine we want to find this full angle here. We'd have to find these two, okay, and then add them together. This one would be overly difficult, but some could be slightly more. And also find the angle of a non-right angle triangle. And we'll take a look at that coming up in another example.